welcome back to Beyond the Lab. Today we'll be talking about the origin of the universe and how everything began. So, there are multiple theories about how the universe began. The most popular theory is cosmic inflation, but then right under cosmic inflation there is primordial nucleosynthesis. So I'll explain a bit of both, but mainly cosmic inflation in this video. I might make a later video talking about primordial nucleosynthesis. So, at the beginning of time, t equals 0, as Stephen Hawking says, before the Big Bang happened, there is nothing. So, Stephen Hawking used this example. So, imagine Earth, it's a round surface. So, the South Pole is t equals 0. And there is nothing more south than the South Pole. That's how Stephen Hawking described the universe and what's before the Big Bang. So, shortly after t equals 0, actually immediately after, the universe started expanding rapidly. The universe was propelled outwards by dark energy, and kept on going, and it's still expanding right now, even after 13.7 billion years. At the beginning of the Big Bang, the four fundamental forces that we know now, gravity, electromagnetism, the weak force, and the strong force, were all unified into one grand unified force. So then, afterwards, the strong force split from the other three forces. Then after that, gravity split from the electromagnetism and the weak nuclear force, which then we call the electro-weak force. Then after some time, it's split into electromagnetism and the weak nuclear force. But even now, electromagnetism is made up of electrostaticity and magnetism. So let me just explain what these four fundamental forces do. So the strong force is binding the atomic nucleus. Gravity binds celestial objects like planets and stars. And the weak force is responsible for some atomic decay and also some forms of radioactivity. Then electromagnetism binds atoms together. So right now your body is being held together by electromagnetism. So in the cosmic inflation theory, the universe became so hot that no atoms could form yet until later on that the universe cooled down enough that there could form helium and hydrogen atoms. So that's when light actually started traveling around, because before atoms started to form, electrons were bound to photons, which are packets of light or like particles of light. So electrons were bound to those packets of light. So we can't technically see into the Big Bang, as you would imagine, since light takes time to travel. So in theory, we could see it to the Big Bang the farther we looked in the universe. But light hasn't begun to travel at that time, so we wouldn't really be able to see the Big Bang no matter how far we look into the universe. And as Neil deGrasse Tyson explained in his book, Astrophysics for People in a Hurry, that if you were there at that time, it would just be blurry everywhere. We wouldn't be able to see anything because the photons hasn't properly started traveling yet. So, then how do we know that the Big Bang exists? Well, actually, we don't really know that the Big Bang exists or not, but everything points towards the Big Bang existing. For example, the farthest thing that we can see into the universe, or see into the universe, is the cosmic microwave background radiation, also known as CMBR, which is this microwave radiation given off around the Big Bang happening. So with the CMBR, we can observe the time before the Big Bang, time after the Big Bang happened. Well, now that the universe is formed and expanded so much, we should be able to see really far into the universe. Well, not quite. We can't see that far into the universe because, well, only 5% of the entire universe is actually made up of normal matter. So then what's the other 95% of the universe? Well, apparently 68% of the universe is made up of dark energy, which is propelling the expansion of the universe, and dark matter, which we can't observe for now, is taking up 27% of the universe. So no matter how hard you try with radio telescopes, with microwave telescopes, you won't be able to see that far into the universe no matter how hard you try. If you want to observe cosmic radiation, there's a really simple way, really simple actually. If you build a cloud chamber, which is surprisingly simple to make, you can actually visualize the path of cosmic radiation. The experiment is really cool. I definitely recommend you try it out. So that's today's video. I hope you've enjoyed it, and we'll see you in the next video.